going to take a look at number 27. 27 is a really great problem, probably one of my 4 or 5 favorite problems in this book. Anyway, you've got two different poles. One's 10 meters tall, one's 70 meters tall. The two poles are 100 meters apart. We want to connect a line from the top of one to the base of the other, and then the top of the other to the base of the original one. And we want to find the height above the ground of the intersection point. So we want to start out here just kind of making a sketch, and I don't think this has to be perfectly to scale, but anyway, you've got a 10-meter pole here, you've got a significantly taller 70-meter pole over here. We do need to assume that they're both perpendicular to the ground. They're 100 meters apart, and we're connecting a line from the base of one to the top of the other, and then from the top of one to the base of the other. We're getting something that looks like this. We want the height, which of course is also going to be perpendicular to the ground. We want that height right there, or rather maybe I should label that height right there. That's what we're looking for. So anyway, the diagram is a big piece of this. Now, if you look at that real carefully, the first question is, are those triangles similar to each other? And if you notice, they both got the right angles, they both got a length of 100 meters here, but you'll notice you've got a length of 10 meters there and of 70 meters there. That is not going to meet the side angle side requirement for similar triangles. Those are not similar triangles. One's basically, in fact, if I had drawn this to scale, really, one would be very long and thin, and the other would be kind of more balanced. So anyway, those are not similar. However, there are similar triangles here. If you take a look at this triangle here, this triangle inside that triangle is similar to the whole thing by angle, okay? If you take a look at this big triangle over here, this triangle on the inside is similar to the whole thing as well. Because I have two pairs of triangles inside triangles, I'm thinking I can add a second variable here and do a system. I'm going to call this length x, okay? If this whole length here is 100, that means you could take away x from 100, and that would give you a representation for the other part, okay? I do not want 3 variables here. If you think back down to number 1, if you've got 3 variables, you need to write 3 equations. I don't think I can do that. But anyway, so I'm going to take this triangle right here, and I'm going to break it down. What do we have? Well, we have a big right triangle with a height of 70 and a base of 100. Okay, does everybody see that original triangle, height of 70, base of 100? Okay, we've got the little triangle inside it with a height of h and a height and a base of x. Okay, so we could set that up right there. So there are those two triangles. I can definitely set up a proportion with those. We've got a height over base ratio here. That's 70 over 100, which is going to simplify down to just 7 over 10, height over base. And then I can compare the height over base here as well, and that's going to be h over x. So there's a proportion. It's got 2 variables, so right now we can't solve it unless we get another equation. Well, I can come back here. I've got this triangle with a similar triangle inside it. Okay, so let me draw that. We've got the big long triangle with a base of 100 and a height of 10. Okay, we've got the little triangle inside it with a height of h and a height of 100 minus x. Okay, it's the same kind of thing. I can do a height to base comparison here. The height over the base is 10 over 100, which is going to simplify it down to 1 over 10. Height over base here is going to end up being h over 100 minus x. Okay, I'm going to solve these two things, or at least try to get them out of proportion form. If I cross multiply here, that's going to be 7x is equal to 10h. Okay, not sure what to do with that yet. Let's cross multiply this one. 1 times this is just going to give me 100 minus x. 10 times h is going to give me 10h. Okay, and pull back and look at those two equations. Notice something. I was surprised when I noticed this. These two equations are both equal to 10h. So I thought I was going to have to solve for x or for h and to substitute in one of the equations, but they're both equal to the same thing, which means that 7x has to be equal to 100 minus x. And if you kick the x over there, you get 8x is 100. X is going to be 12.5. Okay, so we can go back to the original diagram. We can fill in a 12.5, or we can go back to one of these other diagrams. And in fact, we can probably do this really quickly at this point. Let me see if I can find one that we could do here. Well, let's just go back to this proportion right here. If x is 12.5, well, if you're looking back at the original diagram, we're saying this length here is 12.5. That's going to make this length over here, I think that's going to make that 87.5 is what will end up happening there. But anyway, if you go back over here, you can just substitute it into this little equation here. That's probably our most simple equation. If that's 12.5, we could substitute 12.5 into the little portion here. And anyway, you can take 7 times, wait, not 7.5, sorry. X is 12.5, right? Sorry. 7 times 12.5, okay? And anyway, 7 times 12.5, I believe is 84.5. And that's going to be equal to 10 times h. So you end up with that, and that means h is going to be 8.45 meters. And so that's our final answer here. That's equal to wait a second. I'm sorry, I made a slight mistake here again. 7 times 12.5 is 87.5. So it would be 8.75 is our final answer there. There we go. Okay. So we're going to have a height here of 8.75, and that's the final diagram.